For day 8, we have a situation where a person is pulling a string, and the picture we see it's that way, causing the block to move to the left at constant speed. Constant speed means acceleration equals 0, and the net force equals 0. There's a constant speed of 0.2. Force shows 4 forces on the block. Tension T in the string, the normal force, weight, and friction. The coefficient of friction is 0.3. Rank the magnitudes of the 4 forces. Well, we have 2 dimensions, so let's look at 2 different free body perspectives. So let's do the horizontal. We have the force of friction, and we have the tension. We know it's traveling at constant velocity, so F net is the sum of the forces. F net is ma, and the sum of the forces is T plus FF. Acceleration is 0, so T is equal and opposite to FF. Rank the magnitudes. T equals FF. Now, of course, we could just see that by knowing it's constant velocity, but I want us to continue to look at how we can track things down here with using Newton's second law. Now, if we do it vertically, we have the net force is the sum of the forces, and ma equals Fn plus the weight, Fg. Acceleration is again 0. It's not accelerating up or downward. And the table. So it's being pulled along a table. So Fn plus W. So Fn is equal and opposite to the weight. So the magnitudes are equal. So we know Fn equals W and T equals FF. But how do they compare to each other? The connection between these 2 sets of equations is through the friction. Force of friction is mu Fn. And the mu, we are told, is 0.30 Fn. So if the force normal is 1, force of friction is 0.3. Therefore, normal must be larger than the force of friction. So then, we have force normal is equal to the weight, which is greater than the tension, which is equal to the force of friction. Now, of course, to justify this, we need to explain that. And what we might say is the block does not accelerate in either the horizontal or vertical directions. It's not moving vertically and is moving at constant velocity horizontally. Since F net equals ma and a equals 0, then the net force equals 0. F net is the sum of the forces, which are T and FF horizontally, and force normal, and the weight vertically. Since both pairs add to 0, each of them is equal and opposite to the other. And we want to qualify it so it's clear. T equal and opposite to force of friction, and W equal an opposite to Fn. Since force of friction is mu Fn, with mu 0.3, then the force of friction is 0.3 Fn, and the force of friction must always be less than Fn. Thus, Fn equals W, which are greater than Ff equals T.